Alright, so Fanatical asked me to talk about component rating a little bit. It's actually kind of a difficult subject because, for the most part, with components, you're always going to have to look up the data sheets in order to find out what their ratings are. But there are a couple of rule of thumb components that you can just generally say, okay, well, this is what that component is going to be rated for. But for others, it's going to be a little bit more complicated. So, for instance, your average ceramic capacitor, like these guys here, you're going to be looking at 50 volts for those. You won't want to exceed 50 volts. These are the ones that just have the capacitance stamped on them. If they have a different voltage rating, they're going to be printed on the capacitor. For instance, these radial capacitors right here, which say right on the side 220 microfarads, 16 volts. So you don't want to take this guy over 16 volts. Otherwise the electrolyte on the inside starts to boil and then it explodes. Then we've got these metal film capacitors right here, which are printed right on the front, 275 volts AC. So then you know that they're rated for 275 volts. These are main suppression capacitors, which is why the rating is in AC current. And then we have resistors, and I've got tons and tons of this. So these are quarter watt resistors. Now, resistors have no real voltage rating. And that's why they're rated in watts. So generally you don't want to exceed 600 volts on one of those carbon film resistors, but you can put 1,000 volts through if you want. It's not going to hurt it as long as you keep the current rating. So we've got our standard P equals IV, correct? So we know the power rating is going to be 0.25 watts. We don't know what the current is going to be, but let's say we're putting 1,000 volts through it. So if we grab our calculator, which I currently have covered in components, bear with me a second here. Although I should be able to do this in my head, I'm just going to do the math here. So we have to divide this side by 1,000. Then we have to divide this side by 1,000, right? In order to get our current rating. So 0.25 divided by 1,000 is going to be equal to 0.00025 amps. Now, if we move the decimal point over 3 points, we've got, oh, I'm going off screen here, 0.25, oh, the stupid pens, I really wish they'd stop doing that. Let's grab one of the new ones. So 0.25 microamps, or 250 sorry, this is 0.25 milliamps, and then it's going to be 250 microamps. So while you can put 1,000 volts through a quarter watt resistor, you can only put 250 microamps through it before it starts exceeding its current rating. Also keep in mind that if you're driving a resistor at its rated wattage, rule of thumb is that it will operate at about 100 degrees Celsius. So at 250 microamps, that little quarter watt resistor is going to get really super toasty. So that's just your quick explanation of how to determine the rating of resistors, and I guess we also briefly touched capacitors. Now, as far as everything else, semiconductors and such, you're pretty well stuck with having to look up the data sheets. And I'll kind of give you a quick demonstration why. Because let's go with diodes. So 1N4007 diodes, pretty bog standard. Everybody knows they're rated at 1 amp. They've got a PIV of 1000 volts, which means that the maximum amount of voltage that they can block when reverse biased is about 1000 volts. Bog standard, I was going to say dime a dozen, but they're more like dime for 100. See them everywhere. Rock solid design. You know, they haven't changed in years and years and years and years, right? So how about these little guys? Looks exactly the same package-wise. Let me I'll zoom in a little bit there. Anyway, exactly the same package-wise, exactly the same size. The only thing that's different visually is the fact that this one is printed with 1N5819, and that's a Schottky diode. This one is rated at, I'm actually going to, because I just had a brain fart and I can't remember. I'm going to look that up and I'll be right back. Alright, so I did remember correctly. So the 1N5819 is rated with 40 volts PIV. So much, much, much less reverse bias voltage handling than the 1N4007. It's still rated at 1 amp, but it only has a forward voltage drop of 2.5 volts. And that's what's special about a Schottky diode. They also have a very fast recovery. So, functionally identical package, but wildly different voltage ratings. Let's throw another thing into the mix here. This little guy here. This is a 1N4936, which is a 1 amp, 400 volt PIV diode, but it's a fast recovery diode. This is a fast recovery silicon diode as well. So this is more of a higher power signal diode. When I talked about signal diodes probably last week, I said they have a much lower, in general, they have a much lower voltage and current rating, but you can get fast recovery diodes that are rated higher. They're just very expensive. So let's have a look at yet a different package, this big thing. This is another Schottky diode, but this one is rated 40 volts at 3 amps, so it's much larger. What other examples do I have here? Ah, yes. And then there's these big honkin' things here, which are 6A6 diodes. They're 6 amp, 600 volt diodes. So as you can see, we've got visually similar packages, but widely different component ratings. So unfortunately, generally, when it comes to component rating, you're going to have to look it up. But there are a couple of ones that are just ones that you should memorize, like the 1N4007s. You just got to do your math with the resistors. Capacitors, it's generally printed on the capacitor what their ratings are, except for those little ceramic capacitors, which rule of thumb on those is 50 volts. Anyway, I think that pretty much covers my brief discussion on component rating. If I left anything out, or if you have further questions, go ahead and start a discussion in the comments below. If you haven't already, consider clicking here to subscribe. Right over here will be a video that YouTube thinks you'll find interesting. Right here will be the Back to Basics playlist. And right here will be the link to Patreon, which you can use to support the channel. You also get these Back to Basics videos 3 to 5 days in advance. Thanks so much for joining me, and we'll see you next week. Bye-bye.